Alright, so today we are recording and learning about angle relationships. So you should be on lesson 7, day 1. First task is a little review, doing some warm-ups. Try them out, and then ask us to check your work before you move on. Alright, vocabulary for today. Adjacent angles. These are two angles that have a common vertex and a common side. What you should be able to see is this whole angle is made up of these two smaller ones. So the side CD is their common size, and or CB, excuse me, and that common vertex at B. Vertical angles are two non-adjacent angles, so they're not directly side by side, formed by two intersecting lines. Key thing is that you'll always find that X shape when you're looking for vertical angles. They will always have the exact same measurement. So any angles that are opposite of each other on that X are going to have the same measurement. And your linear pair is two adjacent angles that create that straight line, those opposite rays. So you can see I have angle DEV and CEV come together, making a linear pair. They will always add up to 180 degrees because it creates that straight angle situation. And so we're taking a look at our picture. We want to know if these are adjacent, vertical, or linear. So remember, we would look for the X on the vertical and that they make that straight line on the linear pair. These guys will just share a side. These will share a side and make this straight line. It's angle 1 and angle 2. And we're going to make sure I can see them there. They are stuck together, sharing that side. BQ makes them adjacent. Next, angles 1 and 6. And I see them right here. So when I see them opposite each other like that, I would always want to look. Do I see that X shape? And because I do, I can call them vertical. Excuse me. Let's try that again. That was not 1 and 6. 1 and 5 are opposite of each other. You see the X shape, that makes them vertical. Trying 1 and 6 again. 1 is here, 6 is here. I see angle 1, I see angle 6. They are sharing a common side, coming together to create that straight line. So while they share a side, making them adjacent, they also are special because they come together to make a straight line. So we would say that they are a linear pair as well. And last, angles 3 and 2. And I see them up here. They are side by side, sharing that side QU. But that's it. Nothing else is special. So just adjacent. So we are referring to this picture. We need to identify two obtuse vertical angles. For the vertical, we're looking for the X. For the obtuse part, we got to find the two fatter sides of that vertical angle. So looking at my picture and finding the X shape, you can see that it's there. Looking for the fatter sides of it, I can tell what my obtuse angles are. This side and this side. So now I need to whole name it. I start on one side of the angle, go to the vertex, and then on to the third side, the second side. So angle R and T, and from the other side, same thing. Start at one end, to the vertex, to the third point, angle S and U. Identifying two acute adjacent angles. All we need to do on this is make sure that they are angles clearly less than 90 degrees and sharing a side. It doesn't matter which pairs you choose as long as you pick two that are stuck together. So for example, maybe you say angle R and B, and T and B. That's perfectly fine. No problem with that at all. You also could have chosen entirely different ones, like S and R with R and B. And you could have included U and T and T and B. That's fine too, as long as they are stuck together and less than 90 degrees. And last is just identifying a linear pair. The only place where it has some angles really coming together on one whole line, nice, well, I guess it's not the only place, but one of the places is on this line. I could choose two angles here that create that line, so perhaps I say T and R. And S and R. That would create a linear pair. You could have said T and B and S and B as well. So that would have been these two. Or something like U and S and R and S. Again, it's any time you could find a pair that meets your criteria. It would still be correct. So look. Alright, so we are identifying the angle relationships and using them to solve for x. So again, we can have an adjacent angle situation, a linear pair, or vertical angles where we see the x. Looking at number 3, we got to decide what we know. They are adjacent, but they also are a linear pair. I can see they all come together to make that straight line. And if it's 90 degrees on here, what do we know about the other side of it? That is also 90. So we're just going to utilize the adjacent angle situation to say that the 2x and the 7x together have to be 90 degrees. So combining like terms, 9x is equal to 90, solving for x. So x is 10. On my next example, what do I have? Still a linear pair. So I know that the two halves of a linear pair are going to add up to 180 degrees. Combining my like terms, 7x and 2x makes 9x, 4 and 5 makes 9, and then solving, subtract 9. And then we would divide by 9. Means x is 19. And my last example, taking a look, what is that relationship? And I see that x, so immediately it should tell you vertical angles and that they are congruent. So 7x plus 7 is equal to 70. Solving for x, start by subtracting 7. And then divide by 7. So x is 9. finding x here. We have to find x, the measure of AEC, and the measure of CEB. So it's three things to do. Really, all we're doing is finding x, and then if you look at the names, we're just plugging back in. So I see that relationship, they're vertical angles. So I can set them equal to each other and solve for x. So x is 24. Then to find our other missing pieces, the measure of angle AEC. So AEC, that's the 3x minus 8. That is 64. And then the measure of angle CEB. That's the other side, 4x minus 32. So that is also 64. And we know then that we've done our work correctly because we got the same answer for both those angles. And then here, we are again finding x and the measure of each of those angles. So using my relationships, I can see that that's a linear pair. Linear pairs, we know, add up to 180 degrees. So I just add the two angles. And we will combine our like terms. So 7x plus 4x is 11x. Negative 11 minus 7 is a minus 18. Add 18. So 11x is equal to 198. And divide by 11. Means x is 18. So now we have to find the measure of angle MRQ. So looking at my picture, MRQ is here. These also create vertical angles, which means I know that opposite angle has the exact same measurement. So MRQ is 4x minus 7. But x is 18. So MRQ is going to be 65. Then I need the measure of angle NRQ. And that one is actually here, and the vertical angle is telling me it's the same as the angle opposite, so it's 7x minus 11, but x is 18. So the measure of angle NRQ is 115. In summary, if we look at this picture to the right, naming a pair of congruent angles, well, we got vertical angles, so angle 2 is going to be congruent to angle 4, and angle 1 is congruent to angle 3. Which of these are the acute vertical angles? That's angle 2 and angle 4. Which ones are the obtuse vertical angles? Angle 1 and angle 3. I need a pair of linear angles now. There's 4 possibilities. So again, it's any pair that'll make a straight line. So we're going to start with 1 and 2. Then I could continue the other way. So I could also have 2 and 3. We can continue our way around. Angles 3 and angle 4. And then the last pair, angle 4 and angle 1. And then the measure of angle 3, it makes a linear pair, so it's 180 minus 65, which is 115. Homework, you're choosing 2 questions from the